Okay, so let me just on. Welcome to the second in the series, Mechanical Rigidity, for the Reprap Wiki series on 3D printing. So, the first one, I must apologise, I didn't realise that the microphone would have such a dramatic effect on the microphone would be affected by tape going crinkle like that. It takes a while to reset, so I apologise for that. Now, so the first one I did was a cube. This one, what I want to do is the toblerone shape, which was for both the Delta printers, the Kossels, and also for the original Mendel. So let's start with the Delta printer, demonstrating that it's completely inadequate. All right, this is your average Kossel printer, plastic in the corners, and it's just, it's dreadful. I'm just sort of amazed that anybody can get any kind of quality out of this, because you get twisting on the top and you get shearing both, in all directions. So I'll go on to explain how that can be braced, but basically have a look at the fissure, because they used really effective. That's a fantastic design. All of the problems of the Kossel are gone in the Fisher 3D printed design, because they use panels, as demonstrated in the previous video. They use panels here, but they're up to this height thing, with this picture frame board around here, so you can gain access to the thing. But that completely makes the entire frame absolutely rock solid. So that's a fantastic design concept. Now, I haven't taped this up deliberately yet, because I wanted to show you what this is basically the original Mendel. There's a piece of plastic across here, and opposite at the back here, back there, which then the Z-axis goes into. Now, if you can see, basically what happens is that provides a pivot point, because this is basically a rhombus, and it's a free moving shape. I'm just amazed that, I know that the Mendel is the iconic design, started the 3D printing movement, but I'm just sort of amazed that anybody was able to do anything at all. They weren't. In fact, I have a friend who has one, and the parts used to regularly explode into bunches of spaghetti. Yeah. So, so this isn't actually that much of an issue, because the carriage moves backwards and forwards, hit side to side, so it doesn't cause, because the carriage is moving side to side this way, it doesn't cause this to go wobble 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 like this. So in the MendelFlex and other designs which still have this rhombus effect here, they're okay. All right, this one isn't that particular issue of this isn't a problem. So what I'm going to do is just assume that that's fine, all fine. Let the microphone reset. 1, 2. Now we have our proper, the Toblerone shape. Now, the problems with the Mendel design that you really need to know about is this. One, all right, you get this, the triangle here basically twists and lifts the entire, unless you're operating a Mendel printer on a solid surface, you are in trouble. All right, it's as simple as that. And even if you move the printer even a fraction, you need a total reset. All right, you need to do print bed re-leveling and check that everything's okay. You cannot move a Mendel style printer without doing a total reset. For this reason, that the front one of the triangles will rotate. And any kind of movement like that will basically, twist the entire bed, and you're out. You're done as far as the thing. You need to totally recalibrate. Second thing is, if I lift it up like this, that's your base. and it's twisting like this. I mean, it's just, you know, ridiculous. So it doesn't matter that you've got the Y rods across here. There's no bracing whatsoever in the base at all. You're going to get that entire base panel is going to be parallelogramming. And the third deep design flaw obviously is this, and that's basically as the carriage is going backwards and forwards, one thing, you're going wobbling forwards, and it's just I'm trying to avoid using derogatory words on something that's such a classic, iconic design. But all of these things, they're basically inspired in time movement, inspired things to do better. All right, so Mendel90, the MendelFlex, Mendel Max, and all these ones, the lull spots, all these ones, you know, inspired people to do that. So okay, so this is the part about where we'll put some bracing in on these 3 panels. To demonstrate that if you try to do this kind of bracing on a MendelFlex, well, of course the print bed's going backwards and forwards like this. It's just, you know, you basically don't get a Mendel design printer, please. Mendel90, fine, no problem. MendelFlex, no problem. But the China cheap clones, where you see the copy of the original Mendel design, just please don't do it. All right. So we demonstrated the effectiveness of this. Whoops, I put that one off center in the cube design one, but I wanted to show you for this as well. All right, so we'll pull that tight, and that will, yeah. So that thing, that's not going anywhere. All right, so you see how effective that is. Now you could do that for the base. You could have a panel in the base, and your print bed going backwards or forwards will still be a thing. The moment you fill this in, you've totally stopped your printer from being able to operate. But you could use an open frame panel, and it would stop the thing. So let's do that, and I won't cut out, but what I want to cut out is the panels for the fissure. Right, show you how effective it is. The fissure design really is. So one. Let's a mistake I made previously in the cube design was I didn't stretch these enough. It was quite useful to see the crinkling that occurs, but also it doesn't really use. You think, oh, he's using paper. That can't possibly be a good demonstration. Bloody well it is. Precisely because of that crinkling, it shows you clearly and very visually and to good effect. Where the sorry, I could put the tape at the same time as speaking, where the structural loads are transferred. And let's pull that one tight. Ah! Yeah, pull that tight, put it on, and pull it tight. Awesome, that's quite tight, it's tighter like a drum. Fantastic now, nothing. So let me see if I can tighten that one up more effectively. Yeah, I think so. The better the attachment to these along these points here. You want at least, like I demonstrated in the cube one, you want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 attachment points for one piece. That's a thing to make sure. So the absolute bare minimum you want is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, because you do not want this to occur. All right, with a panel. All right, so particularly when you have the Delta printers. The Delta printers is typically sort of really quite high, high up. Consequently, things like this happening, bowing here on the panels, really starts to matter. All right, so let's cut a hole out to show you what the fissure looks like. And you will see that it's still okay. Now that twisting is because of the paper, because I don't think, but can you see those bowing points? That indicates to you where the structural load will be transferred to. Now if I also put a piece of tape here and here, which represent the screws that you will, it's got attachment points that you will need for the, there, this should now, yeah, look at that, the thing, the top part half there is not going anywhere at all. You can still see the thing. Now this is basically, this stress on here will, will be pulling the panel at this point, so you do not want to make this too thin, even with you if you were using like an aluminium plate. An aluminium plate, you wouldn't want to do anything less than about 25 millimeters. An acrylic, 3mm acrylic or MDF or whatever, or hardboard, you don't really want to go less than about 40 millimeters on here. And certainly you want to make sure that the distance from here is significant as well. Put a curve or a diagonal piece across here. Don't just put it straight like that and thing, because you will get that. You can see it's the thing, and if you put too much, it will just split the thing, just like it did on the paper on the previous video. So, put it in the wrong damn place, haven't I? I meant to be in there. Oh, well, okay. If you had a Mendel design, your print bed could come down like this. Basically, on a Mendel design, you cut that whole thing out like that. Put the thing on the wrong place. Sort that for you and show you properly where it's supposed to be. One. Yeah. Put it under tension whilst attaching it. 2. Now we should have a when this 4th piece goes on, we should have a solid cube. It's not a solid cube at all, it's a room. It's a toblerone. Ooh, look at that. I managed to get one right. So that's what I'm saying, it's still got a tiny amount of that seems thing. Anyway, I apologise. The fissure has a cutout like this, and the delta bits go inside, so you can't get access to the delta bits, but you can actually get access to the thing that you're printing. Yeah. Alright, so let's do instead of a straight into the corner, let's do a diagonal thing like I was talking about. Octagon shape, that's the one. There, not too much, not too much. Wah, wah, wah. Wah, wah, wah. Okay, all right. 2 pieces. One across here. Da, da, da. Okay, so this quite important. Oh, it's torn already. It's quite important to make sure that these attached with thing, these shapes on the fissure, they go all the way around, because you want attachments. Yeah, you get the idea. All right, so Right, you can see that flexing about because it's pulling on the things. It's not quite thing. That's basic principle of what the fissure is about. Even here you can see this is flexing about. You want internal bracing if you've got space, or if not, you want a 360-degree brace on the outside here. All right. In your particular design, you might have the delta z-axis rods going up and down here. You can't fit something on the inside here, which would stop these from going 1, 1, 1 like that. But that is quite critical, especially because the delta printers are quite high. Let me just check and see. I've lost the end of the tape. If fixing that does the job. Yeah, that's bowing the. It's actually what's happening is it's the tape under stress is pulling these in, and so that's bending inwards, resulting in a thing. That's probably because of I didn't do it as across there. Yeah, you can see that's bowed inwards, which if I had the full panel in here, that wouldn't actually occur. Not perfect, but pretty damn good. So that's 2 demonstrations, one for the Mendel and one for the Kossel Delta printers. Thank you very much.